Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is IR spectra and lecture number 10. In this case, I will explain you the IR spectra and number of vibrations, how to calculate number of vibrations in IR spectra. Let us see this one. This is infrared spectra, and normally infrared spectra is wave number versus percentage transmittance. Okay, and there are two main parts of infrared spectra. One is from 4000 centimeter inverse to 1500 centimeter inverse, which is called functional group region, and second part is 1500 to 600 centimeter inverse, in which this is known as fingerprint region. Well, normally between 4000 and 1500 we are getting stretching vibrations, and between 1500 and 600 we will get number of bands due to stretching and bending, and therefore number of bands are particularly more in this case. So it is practically very difficult to analyze this part, and that is why it is normally compared with known compounds infrared spectra, and that is why it is called fingerprint region. Okay, so this is the main thing. Even in this spectra you will observe various types of bands or peak or dip, whatever you call it. Okay, if this is kind of a band which is huge, broad, and you see that it goes below 20% transmittance, that means this is called a broad and strong band. Okay, and if this is type of a band where its percentage transmittance below 20 again, and you can see it is very sharp, so we call it sharp and strong. Okay, similarly here you can see a very sharp band, but this band is nearly 50% transmittance, and therefore we call it sharp but medium band. Okay, and here you can see very small sharp peak over here, which is having transmittance below 80, therefore it is called sharp but weak. Okay, here also you can, it is a part of this one, so we can identify this kind of band. Here it is the broad band, but it is between 40 and 60, therefore it is called broad but medium. Here we have this type of band, it is called sync band, and we call it broad and weak band. Okay, so this way we identify bands either broad or sharp and strong, medium and weak. So bands or peaks, they are classified on the basis of shape and intensity. Okay, that is the height of peak. So shapes, with reference to shapes, we have two types of bands, broad band and sharp band. Broad is like this and sharp is very sharp, it is having point. Why broadband appeared? It is due to more polarity or hydrogen bond. This one is due to less polarity. So sharp band indicate less polarity. Okay. Then we have three types of band with respect to intensity. One is known as strong. Then we have medium. and then we have weak. Okay, if absorption is greater than 80%, that means transmission is less than 20%, then it is called strong band. If absorption is nearly 50%, plus or minus 10, then we call it medium band. And if absorption is nearly less than 20%, then it is called weak band. So this way we classify bands like this. Now we have to find out number of bands given by any molecule. So we have a formula for that. So total number of vibrational modes in any molecule are, for non-linear molecule, we have 3n minus 6, where n is number of atoms. In this case, the number of stretching vibrations in case of non-linear molecule, the number of stretching vibrations non-linear molecule are n minus 1, and the number of bending vibrations for non-linear molecule to n minus 5. Similarly, total number of vibrations for linear molecules are 3n minus 5, in which the number of stretching vibrations for linear molecules are again same, n minus 1, but number of bending vibrations for linear molecules will be 2n minus 4. So you have to remember this formula to calculate number of total vibrations in a given molecule. Now let us take examples so you can understand this. First of all, calculate the number of total vibrations in first benzene and second propyne. So let us find out first of all number of vibrations in benzene. Molecular formula of benzene is C6H6. So N is equal to 6 carbons, 6 hydrogen, 12 atoms. So N will be 12 for benzene. So total, and benzene is non-linear molecule because all atoms are not in one line. Okay, Well, it is planar molecule, but it is non-linear molecule, and therefore total number of vibrations will be 3n minus 6, which is 3 into 12 minus 6 equals to 30. Okay, and here the total number of stretching vibrations will be n minus 1, which is 12 minus 1, 11, and the number of bending vibrations will be 2n minus 5, which is 2 into 12 minus 5, which will be 19. So this way we can calculate number of vibrations in a given molecule. Another example is propine. Okay, so the molecular formula of propine is C3H4. It is CH3 C triple bond CH. Okay, and therefore N will be 7. 3 plus 4, 7. And it is linear molecule. As it is a linear molecule, total number of vibrations will be 3n minus 5, where n is equal to 7. So total will be 16. Okay. Now the number of stretching vibrations equals to n minus 1, which is 7, n minus 1, 7 minus 1, 6, and the number of bending vibrations 2n minus 4, which is 2 into 7 minus 4 will be 10. So this way we can calculate number of vibrations using this formula. That's it in this lecture. Thank you so much.